Yeah, yeah. So now I am giving the brief introduction of Dr. Apu Saha. So sir is currently working in the post of associate professor at the Department of Mathematics, National Institute of Technology, Agartala. He has completed MSc with gold medal and PhD mathematics in 1998 and 2012 respectively. Dr. Saha has more than 15 years of teaching and research experience. In the field of research, he is interested on applied mathematics such as optimization techniques, computational fluid dynamics, multi-criteria decision making, topological space, etc. Some of the current projects include water-based renewable computational study on fluid transport phenomena. Equivalent the optimization and multi-criteria decision, Dr. Saha has more than 150 praiseworthy contribution in the reputed journal, book chapter, and conference. He is one of the leading researcher in the relevant field with all quality publication. He has produced the several doctoral scholars since 2013, and Sri Sanjay Chakraborty, who is also co-speaker of this session. And he is also working under his guidance. Now I am telling about the brief introduction of Sri Sanjay Chakraborty. Sanjay Chakraborty is working as an assistant professor in the Department of Computer Science and Engineering, Ishwar Vidyasagar College, Bilonia. He did his MTech in CSE from Tripura University and BE from Tripura Engineering College. Now he is pursuing PhD in CSE at National Institute of Technology, Agartala. Mr. Chakraborty has almost 14 years of teaching experience. His research interest and expertise include metaheuristic, artificial intelligence, soft computing, optimization, etc. He has authored various publications in SCI and SCI extended journals and conferences. Now the floor is open, and I request Apu sir and Sri Sanjay Chakraborty to start the session. Sir.
Thank you, Nandi sir. Let me try to present here. Is it visible?
Yes, sir.
Is it visible now?
Yes, sir.
Okay. So I'll try to explain some of the nature-inspired meta-heuristic technique, actually optimization technique. And Sanjay will show, Sanjay Chakraborty will show how this can be applied by MATLAB. So how MATLAB coding can be done to solve different type of problems, real world problems, using this meta-heuristic algorithms, nature-inspired optimization algorithms. So before that, we need to know what is nature-inspired meta-heuristic optimization techniques and why we use them. Why we will use them? There are a lot of optimization technique we know, but why we will use them? So let us have a short introduction about this technique. What is the main terminologies of this technique? How these techniques works, and then some of the applications. So I am just skipping this. What is optimization? I think you all know what is optimization. Now, for example, some of the examples: finding best solutions of anything, best solution of any problem, then any equation, then minimal cost, finding minimal cost any design problem. So any you have to design any machine and how to produce that machine with minimum cost. Then minimal error when you are calibrating something, some simulation or any machinery, when you want to calibration, how you can minimize the error. Then maximization of the profit, it is a business. In business, always we try to find how we can maximize our profit. And in economics, maximum utility, say you have a product or you have something in your hand, then how you can utilize it with maximum efficiency. So these are some applications, and almost all applications uh, will contain one or other of these designs. Now you can see almost all of the study of science and technology, including humanities, including medical science, need optimization. In medical science, often we have to find if there is any medical image, how we can optimize it to make it better visible, and so that the doctor or the physician can easily find the problem, whether the actual problem, whether it is that is some problem is whether is not there in the picture, in that picture. So we know we have any x-ray picture, we have any x-ray image, we have CT scan image, we have MRI image, a lot of images are there. So we have to apply any optimization technique to make them better. So now this is mathematical problem. So maximize a function, here fx. So whenever we will say maximize a function fx, x must not be a single variable, x will be a vector. So this is a n dimensional vector. So f0 is a function from r to the power n to r, and subject to different conditions. All the engineers and mathematics people and also people from economics, then commerce, they will understand what is the optimization problem. So will be an objective function always, which we have to maximize or minimize, and then there will be some constraint. So that's subject to gix less than equal to bi. So gi matlab here I equal to 1 to m. So we are telling that there are m number of constraint. Constraint means the conditions with which we have to minimize our functions. So if we have to minimize the efficiency of a machine, we have to make some constant. For example, the machine can be used for maximum say 10 hours. At a stretch, it may work up to 5 hours. So there are some restrictions. There may be some temperature condition within 30 to say 20 to 35 degree. So there are a lot of restrictions. So all those restrictions will be constraints, and some conditions, that is range of the variables. So if we consider here our variables are here we have taken r to the power n. So since r to the power n, so we have x matlab x1 x2 up to xn. So those variables here, number of variable is n. So those x1 x2 xn, they have some limitation. That means they have some lower bound and upper bound. We cannot say that they are all minus infinity to infinity. Then there will be a lot of problem to search the actual space. So there will be some range of those variables. So we'll take that lower bound xl less than x less than xu. So for first variable x1, x1l less than x1 less than x1u. So we are defining two bounds, lower bound and upper bound. So the variable may move within this range only. So when this and in some problem there may not be any constraint. Those problems are known as unconstrained problem, and if there is constraint, those problems are known as constraint optimization problem. Now there are some mathematical method by which we can do optimization technique earlier, or till now also for some simple problem we can optimize or we can solve any kind of optimization problem by these methods. We all know calculus method, what we have learned in higher secondary: first derivative 0, second derivative greater than 0. Then in degree courses we have seen, because if the variables are more, then we have taken partial derivatives. So partial derivatives are 0, then some conditions are there. Then we have got calculus of variation, then linear programming problem, then non-linear programming problem, then geometric programming problem, then quadratic programming problem, then dynamic programming problem. Right now, for last few years, there is goal programming problem, de novo programming problem. There are a lot of methods by which we perform the optimization and use those tools to solve any kind of optimization problem. But there are some problems. What are the problems in those? Now, drawbacks of traditional optimization techniques. What we know till now, before knowing these nature-inspired optimization techniques. So what are the problems of those optimization algorithms? Now, first, in those optimization algorithms, generally we consider a initial solution. So the final solution generally depends on the choice of that initial solutions. Now, whenever we are choosing an initial solution,
Excuse
is
me,
that
sir.
yes, yes,
Suraj here. Sir, slides aren't moving.
not moving?
No, sir. It is stuck in the first slide.
Oh, let me see. Let me check. Is it okay now? Is it moving?
Sir, it is in the first
No,
slide.
no, sir. Actually, you can share your entire screen because when you are
Now
moving to the slideshow mode, it is not moving.
okay.
Yeah, now it is in introduction slide.
Okay, let me check again. No, it's not coming. Now, again, same problem?
Yes,
Sir,
sir.
are you in full screen mode now?
Yes, yes.
Because no, not the full screen mode is not visible to us.
Okay, if we do in this way, is it visible now?
Yes, sir.
Yeah,
Yes,
sir.
sir.
In this way, it is visible now.
Yes, but when I go for full screen, it is not showing.
Yes, exactly.
So, will it be okay if we show in this way?
Yeah, perfectly, sir.
Okay. So I have to click all those. Now this is our optimization problem, standard optimization problem. Minimize what I have already discussed. Minimize an objective function subject to some conditions. This is called f0x is called our objective function, and these are called gix less than equal to bi. These are called constraint. So this is a constraint optimization problem. So in some cases, this constraint are not there. At that time, we will say that these are unconstrained optimization problem. So these are some methods that we have earlier used. Calculus method we have already done in higher secondary, and in say BSc we have gone for partial derivatives. Then calculus of variation, linear programming problem, non-linear programming problem, geometric programming problem, quadratic programming problem, etc., etc. These methods we have already learned. So, but what is the problem that we have to move? Why we have to move in these problems? What is called nature-inspired optimization techniques. Sometimes we call them bio-inspired optimization techniques. Sometimes we call them meta-heuristic optimization techniques, etc. So why we need to go in that way? So now see, these are the some drawbacks of traditional optimization algorithms. Now, final solution is dependent on the initially chosen random solution. So in maximum of this traditional algorithm, we have to choose a initial solution. So now when we choose initial solution, and that final solution will be completely dependent of initial solution, so that the final solution will depend how efficient the initial solution is. So now if initial solution is not efficient, then our solution what we will obtain, that will not be efficient. Now how to know what is the actual initial solution? If this is which is efficient, how to know? If we can know that, then we know that what may be the actual solution. Near that actual solution we need to guess something, but this is not possible, because for a new problem we don't know what is the actual solution, so we cannot guess a solution. So that is the one of the main problem, because the problem which will come in real life from industry or from any lab, so we don't know what is the actual solution. So that is the problem. There will be always a chance that it will go to a local optimal solution. This is one. Second one and most important one is maximum jo methods we know, those methods use derivative information, or the functions what are there, they have to be differentiable. But what if a function is not differentiable or not continuous? So if a function is discontinuous or not differentiable, we don't have any answer for traditional optimization algorithm, maximum of traditional optimization algorithm. So, but in industry, there may be a lot of problems. There are a lot of problems which are not differentiable or which are not continuous. So then traditional optimization fails. So when that's why those methods sometimes we call gradient based method, because we need gradient information for those. So, but our nature inspired optimization technique do not need any kind of derivative information. So that's why this is a completely new type of algorithm for which by which we can solve any kind of, if we can solve continuous problem, we can solve discontinuous problem, we can solve linear problem, we can solve non-linear problem, anything. Next, another drawback is those method, any method cannot solve all type of optimization problems. Those existing method cannot solve all type of optimization problem. You have to find only a particular type of problem by which one method you can apply a method. So there is no versatile method that you can use for all kind of optimization problem. So but by nature inspired optimization problem, you can solve any type of optimization problem. That is, this is not problem dependent. So but all those problems we are discussing as existing optimization problem or traditional optimization problem do not have this facility. Next, another is if there is multimodal. So there are say a lot of optimization point, a lot of maximum point of maximum or point of minimum. So say there are 100 minimization problem. Out of those 100, one is global optimum and remaining 99 is local optimum. So in that case, if you use those traditional optimization problem, you have more than 90% chance that you will get stuck in a local optimal solution. But this tradition, that is this nature inspired optimization algorithm, has a facility. They are being designed in such a way that they can escape those local optima. Next, those methods, except some of the methods, maximum method cannot solve multi-objective optimization problem, traditional methods, except one or two methods. That too, there are so much restrictions. Some problems, some methods are there, they can solve only minimization type of problem. Some problem methods are there, they can solve only maximization type of problem. So there are a lot of problems. Then again, if there is that is constraint, so those then they will not be able to solve those problems. So there will be a lot of problems with traditional optimization problem, but these meta-heuristic algorithms can solve multi-objective, even many objective also. Up to 3 objective, generally we call them multi-objective optimization problem. If the number of objective is more than 3, then we call it many objective optimization problem. So even many objective optimization problem also we can solve easily by the use of Pareto optimal solutions. And they are not suitable for solving problems involving large number of constraint or large number of variables. Say in sometimes you can find that for a complicated problem, the number of variable is more than 100 or even more than 1000 also sometimes. So at that time, it is not almost impossible for the existing method to solve that type of problem, because with the number of increase in the number of variables or parameters, the complexity of those problems increases exponentially. So it is not possible to solve those problems when, say, a optimization problem have an optimization problem has 1000 number of variables, then no traditional method can solve those. But this nature-inspired optimization problem can easily solve those type of problems. Now this is meta-heuristic, this bio-inspired or nature-inspired optimization technique. So why meta-heuristic we know? Because meta, this actually search method. Actually we are finding the solution by searching. That is the main theme of meta-heuristic algorithm. We will have some initial random solution, not a single solution. We will take say 50 initial random solution. Those random solution will search the entire space and finally find out which is the best one. So that is the main motto of our meta-heuristic algorithms. And this, since this is a search method, search oriented technique, so two terms is very important. These are called exploration and exploitation. Exploration sometimes called global search or diversification, and exploitation sometimes called intensification or local search. Now let us discuss what is exploration and exploitation, because these two are the main funda of any local nature-inspired optimization techniques. Now what is exploration? Now what I have already said, just try to think that these methods depend on search process. So we generate some randomly some random initial solutions, and those solutions will search the entire space and then find some and then find the actual optimal solution, a global optimum solution. Now what is the problem? Why exploration is necessary? Exploration matlab global search, matlab whether we are searching the entire solution space or not. You know, I think solution space where the optimization solution lies. So first of all, we have to see whether we are searching entire solution space or not. So that is the part of exploration. Whether we are completely exploring the search space or not. So first we need to search the entire space, so that if we can miss some space, some solution space, miss a part of solution space, and the actual global optimal value lies in that space, then what will happen? We will not get the actual solution, actual global optimal solution, and we will stuck in a local optimal solution. So exploration is very much necessary. So the first thing, we have to check whether we are exploring our entire spaces or not. So whoever is working in this field or will likely to be work in the field, first you confirm that your algorithm is exploring the entire solution space. Now after exploring, we are getting some potential solutions. Now say there is a curve, optimal curve, and the optimal curve is going down, and it's the below point is the least point is lies in say x equal to 2. Now whenever we are searching the entire space, say sometimes we can stuck in x equal to 2.5, and all other remaining point are 2.7, 3, 3.5, 5, etc., and your least point is 2.5. So you can think that yes, my solution is then 2.5. This is solution. But you see that actually it is going up to x equal to 2, but your solution you are obtaining as 2.5. So what to need now? Next part is coming, which is called exploitation or intensification or local search. Matlab, whenever we have got a potential solution, we need to search near those potential solutions whether more better solutions we can find there or not. So if we get stuck in 2.5, now we will search with the vicinity of 2.5. Maybe we can find 2.4, then with the vicinity of 2.4, then 2.3, and finally we'll come at 2. So that's why two parties there. One is exploration. So exploration matlab whether we are searching the entire space or not, and then exploitation. So exploitation matlab whether we are searching near the solutions that we have already found as a potential solutions. So whenever an algorithm can balance these two parts, exploration and exploitation, then you can say that yes, this is a very good algorithm. So anyone who is interested to work in this field, first of all, you have to check whether this problem is exploring well or not, then exploiting well or not, if there is any mechanism by which you are searching the entire solution space, or you are searching near the solution, near the say in present best solution, whether you are searching near the present best solution or not, and whether there is a very good balance between this, whether very good balance or trade-off between these two mechanism or not. If you can done these three things, you are exploring well, you are searching, you are giving some random moves, that you confirm that you are not stacking in a local optima, then search near the vicinity of already existing potential solutions, that is present best solution, and then find whether there is a very good balance between these two factors or not, exploration and exploitation. If you can do that, you have got your optimization algorithm. So now these are some how we are coming this. These are not important that much. Now introduction of metaheuristic or local search, bio-inspired or nature-inspired optimization techniques. So metaheuristics are strategies that guide the search process. So what is the metaheuristic? We are telling that how metaheuristic uses or how nature-inspired. What is the main theme of nature-inspired optimization technique? By search process. So what is the role of metaheuristic there? That guiding that search process. How we will search that process, the entire solution space. That is the role of metaheuristic techniques in these algorithms. Now, what is the goal? The goal is to efficiently explore the search space in order to find optimal solutions. Now, these are actually one kind of, you can show numerical solutions, numerical optimization. So sometimes it is not possible within a limited time period to find exact optimal solution. So at that time we will be happy with near optimal solution. Say our actual optimal point is 2 point something, there is a 10 decimal point. That is our actual optimization optimal point. Now we have got say up to 5 point we are getting correct answer. So we will be happy with these 5 decimal places, because after 5 decimal places, whatever is the error, that error will not actually affect the the problem. So that's why we will be happy with those 5 decimal places. So sometimes we will be happy with near optimal solutions if the problem space is very big. Otherwise, if the problem is simple, then very easily you can find the global optimal solution. They may incorporate mechanism to avoid getting trapped in confined areas of search space. I have already told this is. So there are mechanisms that they cannot get trapped in local optima, but still some of the optimization algorithm has the same problem. So you can come with your mechanism. How can you get out of this? How can you get out of this local optima trapping? Now, metaheuristic are not problem specific. Now, today's more advanced metaheuristic use search experience to guide search, same thing. So we are searching the guide. Now, what are the main advantages of meta-heuristic algorithms? First is these are very simple, just a few line of code, or you can manually you can do it this your क्या कहते हैं इसको, Excel or any other computational method. Then these are flexibility. They are flexible. You can change by a suitable that is change. You can make this program to solve any kind of problem. Then derivation free mechanism, you don't need to have that derivative information. The function may not be differentiable. Local optima avoidance, so there is a least chance that you will get stuck in a local optima. And use of entire search space, because if your algorithm explores well, so you can search the entire space. Now these are some type of meta-heuristic algorithm. Some stochastic algorithms are there, some physics related algorithms are there, then some probabilistic algorithm, then swarm intelligence algorithm, then evolutionary algorithm, then immune algorithms, then neural algorithms. So out of these four, generally out of these 6 or 7 type of meta-heuristic, generally evolutionary algorithm, swarm intelligence algorithm, physics related algorithm, and another one is human based algorithm. These 4 algorithms are very popular to the researcher who are working in this field. So, and out of those 4, perhaps the swarm intelligence algorithms have maximum applications in industry or and in academia. So the most of the people have applied swarm intelligence algorithm to solve the problems of industry. Also, there is perhaps you have heard about genetic algorithm. So genetic algorithm, genetic programming, and differential evolution. Out of these all evolutionary techniques, evolutionary algorithm, genetic programming, and differential evolution, these 3 algorithms has also huge number of industrial and real life applications. And here in swarm intelligence algorithm, the most important 2 algorithms are particle swarm optimization and ant colony optimization. So these 2, particle swarm and ant colony optimization, contains more than 60% of industrial applications of these nature-inspired optimization algorithm. They have this nature-inspired optimization algorithm has a huge application in industry. Out of those, these 2 methods is the maximum applications. Now another is based on this particle swarm optimization. Now drone swarm has come, and drone swarm is now a vibrant topic of research. So many people are working in drone swarm, because drones are now a very special kind of topic that whole world is working with it, because any kind of problem now they are using drone to solve those, up to say throwing missile to spray pesticide in your fields. So in everywhere the drones are coming. So now if in one drone, that will not be possible to make large operations, so they are using swarm of drones. So this drone swarm is now a very vibrant topic of research. Now if anyone is interested, you can go there. Now particle swarm optimization. First, let us check particle swarm optimization. So if we can find some time, then other algorithms. So I don't think we can find some time after discussing particle swarm optimization, because Sanjay will show you how particle swarm optimization can be used by MATLAB and how you can solve different type of optimization problem here. So now particle swarm optimization, actually in 1995 by Kennedy and Russell Everhart, they have first introduced particle swarm optimization, and this is derived from 2 concepts. One is the observation of swarming habits of animals such as birds and fish. When swarm of birds, you can see that if somewhere is food, you can throw some seeds or rice or something. After a certain period of time, you may find that there are a lot of birds are coming and eating those seeds or eating those rice or eating those pulse. So, but after say, before say half an hour, there was no information or not a single word was there. Now within half an hour, you can find that hundreds of birds are coming, and same case for fish also. So let us take the examples of bird, because we can see those. Fish we cannot see in that way. So now how it is possible? Say before half an hour there were no birds. Now after say half an hour, hundreds of birds are coming there for taking the food. So how they have got this information? So by making this thing, this modeling in mathematics, this Kennedy and Everhart has got their uh, algorithm known as particle sum optimization, or in short PSO. Now PSO matlab we will take a swarm of bird. So those swarm of bird, actually whenever we will go for programming, they will be our initial solutions. Say a group of bird was there initially, a group of bird was there, they are now started searching food. So how they will search the food and how will go to the optimal point where maximum food is there, that is the model, that is simulation we are trying to model in model mathematically and finding the solution, that is using this mathematical model to solve any optimization problem. Now the PSO algorithm maintains multiple potential solution at one time. We have already seen multiple potential solution means we have generated a swarm of bird, that is multiple solution, that is a group of random solutions. I have already said that we will say 50 or 30. Say let us talk about 50. We will generate 50 randomly generated solutions. So those solutions will be our initial solutions, and in terms of PSO, they are birds or fish. Now during each iteration of the algorithm, each solution is evaluated by objective function to determine its fitness. So we have, since we are going for solving a optimization problem, there will be some objective functions. So each of these fish, each of these initial solution will find the value of optimization problem, that is find the value of objective function to find its fitness. Fitness means now we are thinking about bird, whether the bird is fit or not, how much fit. Now if a minimization problem, if the value is objective function value is minimum, that is the fittest, and in for a maximization problem, if the objective function value is maximum, that is the fittest bird. So in that way you can find the fitness of every bird. Now each solution represented by a particle, matlab each solution is a bird here. Now three things we need to find for successive execution of particle sum optimization, that is position in the search space. So what is the position? It's position of the space. So position of the birds we'll write by xi. So what is the position of the bird in your search space? Next is velocity, with what velocity they are moving, and individual best position. What is the best position of any bird? Say we are going for many iterations, say 10,000 iterations. So every iteration, the first bird is moving from first iteration to second iteration, second to third iteration, third to fourth iteration. Now in this way the first bird is moving. So in which place that bird has the best value, the best optimization, that is best objective function value. So where the bird has the best objective function value, this is called individual best position, matlab best position for that particular bird. So we need position, we need velocity, we need individual best position. Actually we need another thing. This is called global best position. So why I am not telling that? Because if you know all the individual best position, so best of all those best is global best, is not it? So if there are 10 things, so if we know that best of all those 10, so now we can say that which is the global best out of those 10, whose value is best of all those 10 better values. Now PSO consists of just 3 steps: evaluate fitness of each particle, matlab whenever we are randomly generating the initial solution, first work is fitness value, matlab objective function value, to find the objective function value. Then we'll update those initial solutions by individual based and global based, and then we'll update the velocity and position of each particle. Now just these three steps. First we will find the initial solutions randomly, that will be randomly generated. Then we will find its objective function. Then we will find what is the individual based and what is the global based, and based of those we will update velocity and position. Now how? Let us see. So each particles, is it visible, the equation?
Yes, sir.
Okay. Now each particle velocity updated using this equation. This is the equation. This is the actually only equation you can say. Another equation, a simple equation we will find. Only equation you can say Vi t plus 1. T is here number of generation or number of iteration. So in t plus 1th iteration, we are finding the velocity of the particle. So initial velocity of each particle is 0. So in the first round, whenever we have just randomly generated our initial solution, at that time the velocity will consider 0. So first case we will find V1, that is VIT 0 plus 1. So into omega into Vi0. So in that this term will be 0 for the first iteration. So now VIT plus 1 equal to W into VIT. So W is a parameter I am coming, which is what parameter? Actually in initial PSO this W was not there. Initial, whenever Canadian Eberhard introduced PSO, the W was not there. After some year this W has introduced, and now it is universally assumed that yes, W should be there in this velocity update equation. Now it's t plus 1th iteration, the velocity of tth iteration multiplied by W, there is a C1, there is a R1 into xi cap t minus xit. Xit matlab position of the bird in tth iteration. This VIT matlab whose birds velocity we are finding, velocity update equation, velocity we are updating, the position of that bird is xit. Now what is xi cap t? Xi cap t is the best solution of xi till now, matlab individual best what we are telling. So we are updating V1, then till now what is the best position of V1, that is x1, that is called x1 cap t. If V2 we are updating V2, so x2 cap will be the best solution till now of x2. So C1 into R1, these are two parameters. I am coming all one by one, what resembles what, plus C2 R2 into GT minus XIT. So XIT we know the position of the bird in tth iteration, and G2 is global based. Matlab out of these all birds whose position is best till now. So that is GT. Now see what we are doing. We are using the velocity, present velocity. To update the velocity, what we are using? We are using the present velocity. We are using the information of best of that bird till now. We are using the best of the whole swarm till now. So we are using the three information. One is his existing velocity, another is his best position till now, another is the best position of the entire swarm till now. So these three we are using. So I is the particle index. Which number of particle we are updating? W is the inertial coefficient, or not inertia actually, inertia. L is coming wrongly. So W is inertia coefficient. Matlab, why inertia? Because he is moving in VIT. Before the updating of the velocity, he is now moving in a velocity of VIT. So how much weightage we are going to give to that velocity? That is W. How much inertia we are giving to that velocity, existing velocity. So that's why this is known as inertia coefficient. Now C1 is called acceleration coefficient. I am coming again, we'll discuss. R1 is a random number between 0 and 1. Xi cap already I have told that this is the individual base solution. Xit is position of the particle. C2 is called acceleration coefficient. R2 is a random number between 0 and 1. Another random number, not same as this R1. So R2 is another random number between 0 and 1. Gt is position of the best bird in the swarm, and Xit is position of the bird whose velocity we are updating. Next is Vit. Now what is the role of what? W? This role of W is, this is inertia component, keeps the particle moving in that same direction it was originally heading. So जिस direction में ये जा रहा है, so we are trying to put in the same direction so that it gives some weightage to the existing velocity. So that is, we are multiplying by W, and we generally take W, the value of W between 0.8 to 1.2. So what is the exact value? There is no particular such study, or this cannot be fixed, because this based on a problem. Different problem, for different problem, different type of coefficient is fixed, is correct. We have already seen by the experience of many solutions. So you can take any value between 0.8 to 1.2. This may not be fixed. You can randomly change between 0.1 and 1.2. Now what will happen if we take 0.8, and what will happen if we take 1.2? Matlab, if lower value we take and upper value will take, what will happen? Now lower value speed up convergence. मतलब क्या होगा, अगर 0. If we take 0 near about 0.8, it will speed up convergence. मतलब it will first go to the solution, but then there will be a problem. If it moves too fast to the solution, then it will not explore the entire space, and there is a huge chance that you will get stuck in a local optima. Now if you take 1.2, that is higher, say 1.1, 1.15, 1.2, then this is encourage exploring the search space. It will explore the entire search space in a fine way, but then there will be a problem. The problem that there may be some over exploration. Matlab, you will need a lot of time to find your solution. Now second term, C1R1 Xi cap T minus Xit, this is called cognitive component. Matlab, because we are updating ith component, and this is about I. So इसका जो खुद का जो experience है उसके ऊपर depend कर रहा है. So this is called cognitive component. So C1R1 Xi cap T minus Xit. Any question, please? Okay. Now acts as the particle's memory, causing it to return to its individual base regions of the search space. So it is trying to go near the best position of the bird till now he has been experienced. So where his best position till now was, he is trying to go in that position. So this is the part, this is called cognitive coefficient. So there is R1 is a random number between 0 and 1. This can be chosen randomly from any random number generator. And C1 is a coefficient. C1 coefficient is known as cognitive coefficient, and this is generally usually taken as close to 2, generally 1.6, 1.7 in at this type of, and sometimes 1.8 also we take. So this is generally taken very close to 2. Now if we take coefficient limit the size of steps the particle takes towards the individual base. So how much we are trying to get into that present base solution. So that will depend on C1. How much we are interested to go to the present base solution. And next is the third term called social component, because we are looking at the society, who is the best. So someone has say in a village, say someone 12th standard result has been come out. So someone has get 80%, someone was 85, 83, 82, 95 this percent. Now say some boy has got 88%, he will see that till now class 1 to 12 how much I have received. Maximum what he has seen that he has got 92 in class 7. So right now he has got 89%. So he wants to move to his personal best. So 92. So that is XI cap. Now it has been seen that in this exam someone has got 95%. So he will try to move next time that he also can find get 95%. So he has inspired by society. So that is social component. Matlab he is inspired by entire swarm. What is the best solution of the best position of the swarm till now? So this is social component. This C2R2 GT minus XIT. This is social component. Now causes the particle to move to the best regions the swarm has found so far. Now social coefficient also, this is close to 2. Generally it is taken a bit higher than this C1. And this is also limits the size of the step the particle take towards the global base G. So this is again we are making we are trying to go to global base. Now someone may ask, now why then we are taking this local based and this we can directly take global based. So that is fine, we can find the global based solution, but then you will may very much chance that you will get stuck in a local optima. Say in this batch someone has get 95%, so everyone is moving near 95%. So in the previous year or the previous 2 year back, someone has got 98%. So all are missing those 98% and are rushing towards this 95%. So there is huge chance that you may get stuck in a local optima. So that's why all these things are required. Only we cannot take this one. So we'll have a very good chance to stuck in a local optima. Now, how to position? Now, position update. So, velocity, we have already got the velocity update. So, velocity, everything we know, every value we have got VIT plus 1. Now, we will update the position. So, XIT plus 1, the value of XI at T plus 1th iteration. This is value of XI in the previous iteration plus VIT plus 1. So, thus we have got the position of the each particle. Now, once we get the position of each particle, we'll try to find the objective function value. So now again we will find individual waste and global waste. So this will continue till the time that you have met the stopping criteria. So what may be a stopping criteria? There are many type of stopping criteria. Someone may take say number of iteration as a stopping criteria. Now there is a very good concept in this optimization algorithms that number of function evaluation is a stopping criteria. How many times you are evaluating the function? That is so many scientists, so many scholars, so many researchers are now taking that as a stopping criteria, function evaluation. Now time may be a stopping criteria. Say I will run this program for half an hour. So that may be a stopping criteria. Again, stopping criteria may be say if I get same solution up to 5 decimal places consecutively 10 times, we will stop there. So there may be a lot of stopping criteria. So till that stopping criteria, you do the same thing. So what you need to do, you first initiate some solution randomly between this lower limit and upper limit. There is an equation. The equation is lower limit XL plus a random number between 0 and 1. Upper limit minus lower limit. By that equation, you can randomly generate 50 solution. Then for each solution, you update the velocity. You have already seen by which equation we can update the velocity. Now, after updating the velocity, you use the position update function to update the position. Now, once you updated the position of all birds, but first iteration khatam. Now you find the objective function value of or fitness value of each of the solution, find individual waste, find global waste, again update the velocity of each solution, then update the position of each solution, go again find objective function value, individual waste, global waste. Again this will just continue. And initially this Canadian Everhard has taken is for 10,000 iteration. So you can also take 10,000 iteration to solve your problem. If the problem is simple, not much complicated, maximum, so in 100 iteration you will find the solution. If the 10,000 solution we are taking when the function is very much complicated, otherwise 100 to 100 iteration you will get your problem, you will get your solution. Now some applications of PSO you can see. This, just 1 minute. Sorry for disturbance. So now application, this is an economic distress problem. So one of the long-term application, this is an electrical engineering problem, economic dispatch. Some of the electrical engineering engineers may know it. I exactly don't know what is the problem is. So some functions are there, you can see. There's maximum power point tracking in photovoltaic system. This is, you will know by the name maximum power point. That is the track of these things. So this is also applied by some of the engineers and some of the optimization specialists. Then there is called a optimal capacity of gas production facility. So in a gas production facility, what may be the optimal capacity? This is the equation of this. This is minimization of this is our function. You can see how much complicated your function is. So much non-linearity, logarithm is there, x2 to the power minus 0.75, here minus 0.78. So much complexity is there, and these are the values. So they have solved, some of the people have solved this. This is the result. By some methods also they have solved, and finally by PSO you have got the best result. Similarly, 3-bar truss design problem. One problem is there from civil engineering, 3-bar truss design. This is the equation. There is this is minimization of, this is objective function. These are the constant. The first one was unconstant. These are the constant. So, and finally the solution is this. This is the solution. 3-bar truss design problem. We can see that PSO is giving the best solution. This PSO is 263.8958, and all other solution is greater than this. Then again, cantilever beam design problem, another civil engineering problem. This is the equation. This is the objective function, and this is the constant, and finally the solution. This is the solution, and again PSO is giving us the best solution so far. So these are some problems that we have solved by PSO. Any question, please? Any question, anyone? So no question? So thank you everyone. Now Sanjay sir will show us the application, MATLAB application, the uses of MATLAB to solve any kind of problem by PSO method. Sanjay, are you here?
Yes, sir.
Okay, please now you start. So let me stop presenting. You please start.
Is it visible, sir?
Yes, visible.
Okay.
I can see, but other everyone visible?
Yes, sir. Visible, visible.
Yes, sir.
Okay. A very good afternoon to all of you. Uh, I don't know how long I can continue as because I am using the internet from my mobile phone. Here, I'm in a place where we are not getting the internet connection properly. So I'll try to complete as soon as possible. So at first, I want to ask Apu sir, as because I have missed some of his presentation part, whether sir has started from DE or from PSO
No,
only.
no, no, no. I could not get the time for DE, only PSO.
Okay then. Okay. Then actually, sir has told you the theoretical part. Now it is the practical part. We have designed those whatever that is modeled by mathematical equations. We have written the codes for those equations only. So at first we have to know after designing an algorithm, we can check those ability of those algorithms by some functions. So here you can see we have we have defined some functions here. Several functions are there like benchmark functions, then CEC functions. Those CEC functions are very much complicated than the benchmark functions. So here I am showing you these benchmark functions. So in every function, you can see that LB is there. Here we have written LB. LB means this is the lower bound. That's because in every search space, there is it is a starting point and the ending point. That starting point is the lower bound and the ending point is the upper bound. So that one we have defined. The starting point is defined by lower bound. Then we have upper bound. Then we have given the values of lower bound and upper bound. Just for example, if you consider this 22 number function, you just see that the lower bound is 0 and upper bound is 10. And what is the dimension? This is the dimension of the equation is 4. So in this function, dimension is 4. But whenever we are designing a practical problem, in that practical problem, you have to find that how many parameters are there. So actually, those parameters values we have to find by optimization method, as because to solve the problem efficiently, we have to find the optimal values of those parameters only. So these parameters values means the dimension here. So here now you come to the lower part. If we are coming into the lower part, you just see we have defined so many things. The first thing is n. So here n is the number of bars. Whatever sir told you that we are considering the bars. PSO is designed based on the bar. So we have considered that 50 number of solutions. So we will generate at first, initially we will generate 50 number of solutions. Then accordingly, we will update those solutions in every iteration. Every 50 solutions we will update in each iteration. Then when the termination criteria or the end criteria, when it will be triggered, then we will find the written here. So max generation is the means the solutions will update every solution. Suppose we have 50 solutions, so every 50 solution will update in each generation, and by this way we will go up to 500 times we will update every all the solutions. So as we have 50 solutions, we have calculated the fitness of every solution. So for the fitness purpose, you just see here, we have a file, another file in which we have defined those functions. As I told you earlier that we have benchmark functions and CEC functions. So here the functions for the functions for which definitions are given, these are actually the benchmark functions. Okay, so you just consider for this presentation, I have chosen the function number 22. Okay, so according to the definition of the function number 22, all the fitness of every solutions will be calculated. So you just see whenever suppose I am executing the program. If I execute the program, you just see what happens. We have the X matrix. So from the X matrix, it first takes these first solutions with all the dimensions. Okay, solution means solution means values of all the dimensions. Okay, so after choosing the value, it goes to the file this get function ss. So after going there, it goes to the case number 22, as I have given the function number 22. So after moving to 22, according to this code, the fitness of the first solutions is calculated and returned. It is returned to that portion, that a main file of PSO. So accordingly, the first value of fitness is calculated. So accordingly, you just see if we open this F, you just see the 50 values are calculated. Okay, so these are the initial fitness values based on the these are the fitness values based on the initial solution. Okay, so what we have to do after that, we have calculated the 50 fitness values, and from these 50 fitness values, we have to find the best fitness value. So before calculating the best fitness value, we have to know whether this problem is a maximization problem or a minimization problem. So we have considered here that our problem is a minimization problem. So we have checked that we have found that mean of PF means we have kept the value of F here in PF. So from that PF, we have chosen the minimum one. Okay. Accordingly, for that minimum fitness, we have also evaluated the solutions for which we have the minimum fitness value is generated. Okay, that is our best solution. The solution with the best fitness is our best solution. Okay. So after that, our task is to execute the program up to the termination criteria is satisfied. So for that what we did, as you people already described to you earlier, that in every iteration we are updating every solutions. So we have 50 solutions. So for those solutions, we have written code here that for I equal to 1 to 50. For this I equal to 1 to 50, we have calculated the WI. Then we have calculated the VI, means this is the velocity update solutions. You can check here. We have written the code here only, and Sar has shown you that what was the equation for the velocity update. So accordingly, we have written the code. So after updating the velocity, we have checked whether these velocities, the updated velocities, are within the limit or not. As because we have a limit and we have to stay within this limit only. So we have checked whether this constraint is violated or not. If it is not violated, if it is violated, then we have that converted those values into its range. So that's why this code is written. So after that, we have the second solution. This is the solution. The second solution for position. This is for position update after velocity update. We have written the code here. The xi, new value of xi will be previous value of xi plus new velocity value. Okay, for I equal to 1. For if you consider the first case, so for I equal to 1, it will be the xi 1 comma all. 1 comma all in the sense, this colon means all in the sense means all the dimensions. Okay, so accordingly for b also it is all the dimensions. So this is this xi all is the new value, newly updated value. So after this updation also we have to check whether this new value, new solution is within the range or not. What is the range? And for function number 22 here, I have shown you initially that for this function number 2, this range is 0 to 10. Okay, so we are just checking this with this code. Okay, so after checking this, we have got the new solution, new first solution. Okay, so then only we are just calculating the new fitness. As we have updated the solution, so we are now calculating the fitness with the updated solution. So this way we are calculating the fitness for every solution. So you just see after these iterations we have the best value and we have updated value. We have the fitness of the updated values. Okay, so for this we are checking whether these values, here you come, whether these values are whether any of these values is better than the previous best value. As because our motto is to find the final best value. Whatever the best values, whatever the values we are getting, initially we have evaluated the best value. This is the iteration 1. Okay, now our task is to update all the solutions in the second iteration and find the fitness of every solution and check whether any fitness value of the second iteration is better than the best value which we got in the first iteration. So that is checked here. We have checked whether any of the fitness value is better than our previous best value or not. If it is best, we have chosen that one as the best value. Suppose just for example, you just consider that the third solution gives the best value in the second iteration, then the fitness value of the third solution omits the previous best value and it takes the place. Accordingly, the value of the third solution is the best solution. So we are keeping the best solution in the G best. Okay. So after that, what we are doing, we are just this is our iteration part complete. Then after updating all the iterations and calculating the best value and evaluating the best value, we are just increasing the iteration. Okay. So this way, so you just see if we are giving here. So sorry, just a second. So suppose here we are giving a breakpoint. You just see after this part, the first iteration is complete. Means here the second iteration will come. So then after every iteration, we are generating the best value, and this will go up to the max generation. Means 500. Okay. So you just consider here that after every generation, what we are doing after every generation, we are evaluating a best value, and that best value is compared to the previous best value. Accordingly, we are getting the final best value after maximum generation. Means if I am coming here, you just see, if I am coming here and executing the program, then when the execution will come here, means here we have evaluated the final best value of our first run. Means after 500 iterations, whatever the value of the best f, that is already evaluated. Then another part is that these meta-heuristics. These meta-heuristics are of stochastic in nature. So what is this stochastic means? Actually, this stochastic means that whatever the value you are getting in every generation, that is not constant. Means suppose for this problem, you just consider that I think it is function number 22. So for this, I think minus 10.4140 minus 10.40 is the optimal value for this function. So you just check here. Here, if we run it, what happens? Though here the codes are written another way, we are generating only one value. I am going to another one for this demonstration part only. You just see here also I have given the 22. So you consider here that here we have written the code another way. So you just see from here that if I execute the code, then you see. So for this stochastic nature of this Metaheuristic algorithm, what we do, we actually evaluate the best values for suppose for 30 times, and we evaluate the mean value of these 30 times, as because these values vary in every iteration, every generation. So it is taking time. Okay, it will come. You just wait, as I have given is for 30 iterations. Or we can do one thing, we can give for 4 to 5 iterations. Then we can show. Okay, I'm cancelling this. I'm giving for 5 iterations, just for example, for 5. Okay, yes, so not for 5 iterations, 5 executions for 5 times. So if we give a breakpoint here, as you see, what happens? Just wait. Actually, this is a multimodal functions, and in these functions also, in these benchmark functions, we have 2 types of functions. One is unimodal and another is multimodal. So in unimodal functions, only one optimal value is there, but in multimodal functions, several local optimals are there. So it is very difficult for multimodal, very difficult to find out the optimal values from the multimodal functions. So, so that's why it is taking much time. Much time. Just wait. I will show you by another one. We have several optimization problems. As I told you that swarm-based meta-heuristics are now.
Yes, Sanjay tried by reducing the number of iteration or number of functions.
Yeah, we can also do that, sir. We can also do that. But I'm choosing another one which is very much faster, I think. I'm doing the NF is iteration here, so we are giving the iteration, suppose just 50 here, 50 here, or we can give 10 also, no issue. So we execute by this, and we are giving here. So now it will come faster, I think. So you just see, it has come very fast. So, oh, this is for the first time it has come, sorry. Now if we give here, oh, another thing is happening here, j equal to 1, I think, yes. So what we have to do, just for 30 times, we are doing this. So what do you have to do? You have to run it. Now it has come. You just see. So for every 30 times, for 30 times we have got the 30 values. Okay, 30 values of best fitness means in the first execution it has got this one as the best value, in the second, and so on. For every 30 iteration, 30 times executions, it has found these values. Okay, so if we run this one, Now from this, you just see from this one. So what we are doing, we are just evaluating the best values of 30 executions. Then we are finding the mean values. We are considering this stochasticness. Now you just run it, and after running this, check the result. Now you see it has shown the convergence curve has also come. So we can see here that the every value of best value of every iteration is shown here, and accordingly this is the mean value, this is the standard deviation, and this is the best value. You just see, though we have given only 10 iterations, then also this is a swarm algorithm. This is WOA, well optimization algorithm. The best value, one of the value is 10.394. As I have mentioned you earlier, that for this function, for this 22 function number 22, the optimal value is 10.40. So only after 10 iteration also it has got a value that is near to the optimal value. So actually this is the interesting thing about these algorithms. So after this, now I want to know from the organizers, as it is only it is already crossed 330. Whether are you allowing me to continue more, or shall I conclude? Is there anyone? Jayanto, Shoniribor sir? Is there anyone from the organizers?
Hello.
Yes.
Hello.
Yes, I want to know whether I can continue, or I have to conclude it, as because it is already 3:35.
Yeah, actually, one more another expert is waiting for this session.
Okay. Then I have shown you whatever I have shown you. That is based on the benchmark functions. So we have several. Functions also. We have several problems, like whatever. I am concluding within 2 minutes, sir. You just see, these are the problems. Whatever sir has shown you, there's gas transmission compressor design problem, then tension spring design problem, then pressure vessel design problem. We have several real world problems. Okay, so this way we can also solve these real world problems, and accordingly find the optimal value using the PSO method, or differential evaluation, or any swarm algorithm, whatever it is. So this is from my side. If you have any queries, please you can ask within 30 seconds. Is there any query from the listener side? No, I think. Okay. Thank you, the organizers, for giving me the opportunity. Okay, thank you. Now I'm just.
Thank you, everyone.
Thank you, Apu sir, and thank you, Sanjay sir, for being a speaker of this workshop. Thank you very much.
Thank you, sir.